Today we will be exploring medians, specifically how to describe a distribution when we consider the center of our distribution to be the median. We have 3 learning objectives, so stay with me. Students will be able to create a 5-number summary for data. Students will be able to explain quartiles in the context of data, and students will be able to construct a box plot for a 5-number summary. Okay, the median. So you guys have probably had a lot of experience with medians before, so let's just review. The median is a midpoint of the distribution. What exactly does that mean? Approximately half of the observations are greater than the median, and half of the observations are less than the median. Write this key idea down. 50% of your data is below and above the median. This is important to know. But how do we go ahead and find the median? To find the median, we have a few steps. Arrange the values from least to greatest. If there are an odd number of values, the median is the center of the observation, or is a center observation. While if you have an even number of values, the median is the average of the 2 center observations. Let's do a little practice together. So below shows the 2016 medal counts for the Summer Olympics. Shown are the top 30 countries. Now these are listed in alphabetical order, not in numerical order. Go ahead, pause the video, and order these from least to greatest. You should have ordered your numbers like this. My lowest number is 9, my largest number is 121, and they go in order. So to find the median, I usually just cross off one from the low end and one from the high end until I get to the median. Now, remember we said that if there are an even number of values in your data set, you're going to end up with 2 center numbers in your center that you're going to find the average of to get the median. I found 17 and 18, so when I add 17 plus 18, I'm going to get 35. Divided by 2 gives me 17.5. Yay! We found our median. 17.5. So we found our median to be 17.5, somewhere between Spain, who earned 17 medals, and New Zealand, who earned 18. Now we want to look at something called quartiles. A quartile divides a data set ordered from least to greatest so that each part represents 1/4 of the data set. So that's what we're going to do right now. We're about to divide our data set into quartiles. And you're probably wondering why, but it gets very interesting in a second. I want you to remember the word quart. In Latin, quart actually means 4 or fourths. So remember, if you hear the word quartiles, you're dividing data into 4 equal parts. We're doing the quartiles so that we can create a 5-number summary of our data. So let's look at what our 5-number summary is. We have a minimum, our first quartile, which we'll find in a moment, a median, the 3rd quartile, and the maximum. So the way that you find the first quartile is that you take that first half and you find the median of that first half. That is your first quartile, and then your 3rd quartile is the median of your second half of data. So let's go ahead and do that. So we already found that our median is 17.5. We also know that our minimum, the smallest value in our data set, is 9, and our maximum, the largest value in our data set, is 121. Let's go ahead and find our first quartile. Now, if our median is 17.5, we know our first half goes up to 17. So again, from 9 to 17, I'm going to go ahead and find the median of this half. I can cross off 9, 17, 10. Okay, so we've found that the halfway point between this first half from 9 to 17 is 11. That's my Q1. Let's go ahead and find our Q3 in the same way, counting off until we get to the center of my data of the second half. Okay, so we find here that 28 is the median of my second half, or my Q3. So here I have my 5-number summary complete. It gives the general gist of the data. My smallest value is 9, my largest is 121. median 17.5. Now when I talk about my quartiles, from up to 11, I have 25% of my data. From 11 to 17.5, I have another 25% of my data. From 17.5 to 28, another 25%. And then from 28 to 121, I have my last 25% of my data. So these quartiles literally divide my data up into equal quarters. So we've just found our 5-number summary. There's something awesome that we can do with our 5-number summary. And this is finding our interquartile range, or IQR. Now, I know you guys have heard of range, and this is your maximum minus your minimum. But we move to a little bit more sophistication in AP statistics, and we want to know about our interquartile range. Our interquartile range is our Q3, our third quartile, minus our Q1. It represents the middle 50% of your distribution. So let's take a look at that using our information here. Okay, so we're finding our IQR, and remember we said it's our Q3 minus Q1. Well, what's my Q3? It's 28, and my Q1 is 11. So now I know that my interquartile range is 17. Another important thing to realize is that between 11 and 28, 50% of countries earned medals within this range, within this interquartile range. So this IQR, represented from Q1 to Q3, contains 50% of data, which makes sense because we said 25% was between the between the median and Q1, and another 25% between the median and the Q3. So we have a middle 50% right here. So now we also want to check for outliers. I know this is a long process, but it's helpful in the end to be able to describe this distribution. So checking for outliers. An outlier is any extreme observation. Before in class we've kind of eyeballed and looked for potential outliers, but here statisticians have actually come up with a very simple rule for determining what outliers are. To find the outliers, you multiply your IQR by 1.5, you subtract it from your Q1, any value lower than that value you get will be an outlier. You also add that value to Q3, any value greater than this is also going to be an outlier. So let's take a look at this on our practice problem.